Hi, we are from Group 2, and our company name is Pertech Solution. And these are our group members, made up of me, Tan, followed by Wafa, Isan, Abdul Yafri Hazwan, and Henderson Fu.
Hello everyone, my name is Numam Ihsan. I will begin with the introduction for our project. Most conventional traffic lights operate using fixed time intervals, regardless of the actual traffic conditions. This can cause unnecessary waiting times, traffic congestion, and wasted fuel, especially during peak hours. To address this issue, our project develops a smart traffic light system using an Arduino as the main controller. The system uses real-time sensors to detect the presence and volumes of vehicles approaching an intersection. Based on the traffic data collected, the Arduino automatically adjusts the traffic light timing, giving longer green lights to busy roads and shorter green lights to less congested roads. This helps improve traffic flow, reduce waiting times, and create a more efficient and intelligent traffic management system. This project has three main objectives. First, to design and assemble a four-way traffic signal prototype using an Arduino Uno microcontroller and compatible electronic components. Second, to develop an automatic control system that processes real-time data from vehicle detection sensors, allowing the traffic lights to adjust dynamically and reduce unnecessary waiting time at intersections. Third, to enhance intersection safety by providing clear and reliable traffic signal transitions for road users. The scope of the project is limited to a four-way intersection controlled by an Arduino Uno. The system focuses on local intersection automation only and does not include communication with other intersections or citywide traffic management systems. These boundaries ensure that the project remains practical, manageable, and achievable within the given time frame.
My name is Henderson Fuanak Chinyin and my number metric is CD240255. So now I'm going to continue our presentation for the critical path method. As you can see, the first one is initiation part where it took around 2 weeks and continue with the planning parts where it took around 5 weeks. In total is 7 weeks, and from this planning part, it divided into two paths where the first one is execution part and the second one is monitoring part. The execution part took around 7 weeks while the monitoring part took around 8 weeks, and then for this both paths will be combined into the closing path where it took around 1 week. So from all of this process, the critical path method shows that the critical path is the initiation part, planning part, monitoring part, and the closing part.
So now is the project evaluation and review technique, or we call it PERT, PERT. So as I said just now, for the critical path method, it start with initiation that took around 2 weeks and continue with the planning part, where it took around 5 weeks in total, and divided into two parts or two paths. The first one is executions around 7 weeks, and the second one is monitoring around 8 weeks. And then for both of these paths, we'll go through a closing part, where closing part took around only 1 week.
Hi, so I will be talking about a Gantt chart. So what is a Gantt chart used for? It's used to arrange each task in each phases, namely the initiation phase, the planning phase, the execution phase, and monitoring phase, followed by the closing phase, into uh, targetable specific tasks so that we can know what we should do in each phase to achieve our result. So these tasks are followed with a task owner, which is the person responsible to ensure the task is done properly, and the duration, which is how much expected time is allocated for this task. And lastly is a timeline, which is how many percent of the task is completed. For the software utilization, the three software that we use here are Tinkercad, Arduino IDE, and Google Sheets. So for the Tinkercad, it's used for us to design the uh, circuit, so we know uh, which circuit will work without us to test us in real life, so we can save time and cost. The second is the Arduino IDE, because to create the circuit we need the Arduino so that our coding can connect with the circuit. So this Arduino IDE will make this smart traffic light. And lastly, followed by the Google Sheets. The Google Sheet is what we use to create a Gantt chart, and it makes uh, organizing the task and following, updating and following up easier.
Assalamualaikum warahmatullahi wabarakatuh. My name is Wafa Nurdiana binti Abdullah. My matric number DD230074. My responsible role in this project was secretary and treasurer, and I will continue this presentation with cost estimation. I will explain the cost estimation for our smart traffic light system. Spertech solution use the detailed engineering method to estimate the product budget. As Dr. Ken saw on the slide, there is a table for cost estimation for our projects such as smart traffic light system. Therefore, the total estimation cost for fabricate one smart traffic light system is RM82. So the estimation cost is assigned as a budget at the completion BAC. I will continue this presentation with the planning for funding source. So for the prototype and small batch production scale, the project can be funded using the company budget. So as a production expand to 100 unit, that estimate the cost increase to 8,000 to 9,000, require the support from the investor. So for the mass production, such as is 500 unit and above, the cost exists 42,000, making bank loan the most suitable funding source. So overall, the funding strategy is designed to support the project growth from the prototype development to large-scale commercialization. So, last but not least, I will present about the earned value management analysis used to evaluate the financial and schedule performance of the Arduino traffic light system. Based on the table that Dr. can see on the slide, the budget of completion was BAC, was RM82, while the actual cost was RM62 and earned value was RM82, indicating that all planned project work had been successfully completed. From the calculation, the cost variance VC was positive RM20. This means the project was complete under budget and generate cost saving. The cost performance index such as CPI was 1.32, which indicate for every RM1 spent, the project generate RM1.332 worth of value. Therefore, the project demonstrate excellent cost efficiency. In the term of the performance, the scheduled performance CPI was 2. This showed the project progressed twice as fast as the original plan. One of the key reasons was the use Tinkercad simulation software, which allow virtual circuit testing and troubleshoot before physical assembly. This reduced errors such as short circuit, incorrect wiring, and coding failure. Finally, the estimation at completion was EAC was RM91.95 compared to the original budget RM82. The project is expected to save appropriate RM20.35. In a conclusion, the EVE analysis show the Arduino traffic light system project was complete under budget, ahead of schedule, and with strong overall project performance. That's all for me. Thank you.
For the project quality management, our quality management involve planning performance benchmark, ensuring quality through continuous code and sensor verification, and controlling quality through rigorous testing. This ensures the Arduino traffic light system remain reliable, accurate, and safe across various traffic scenarios before deployment.
Assalamualaikum. My name is Abdul Rafiq Azwan bin Abdul Rahman, and I will be presenting on the risk assessment. The project identifies two primary risk categories that could impact the successful deployment of the smart traffic light system. The first, uh, the first risk category is technical risk, which we use IR sensors, which specifically TCRT 5000 may experience interference with various factors such as ambient sunlight or dust, leading to false vehicle detection or missed triggers. For the next risk is operational risk. The potential logic errors in the Arduino IDE, which we use in this project, could cause incorrect signal timing, or we should say deadlock, at the four-way intersection of the car. This will lead to many faults and can cause accidents. For the next part is the countermeasure, which is really crucial for the previous problem. For the first countermeasure is the quality expansion. Conducting immediate item inspection upon procurement to verify component functionality with a small budget buffer for replacement parts if needed. So basically, the sensor is needed to be inspected before installing it to the real-time traffic light or real-time use. For the second countermeasure is simulation first approach. This countermeasure can be proceed with utilizing Tinkercad to rigorously test the automated logic and circuit design before physically assembly to identify coding flaws early. So if there is any flaw present in the Tinkercad, the flaw will be solved first before applying the product to real-time tests. That's all for me. Thank you.
In conclusion, the Arduino-based smart traffic light system successfully demonstrates how traditional traffic signals can be improved through automation and intelligent control. By using sensors to detect real-time traffic condition, the system can adjust signal timings dynamically, reducing the unnecessary waiting times on empty roads and improving traffic flow. The success of this project was also supported by effective project management. Through the use of a work breakdown structure, the project was organized into clear phases, including planning, execution, monitoring, and closing. This systematic approach helped the team manage both hardware development and software programming efficiently, ensuring that all project objectives were completed within the allocated timeline. That is all from us. Thank you.